Hi class, today we're looking at B9 homework number 9. So this is the problem that I got. 3x minus 2 over x minus 3 is less than 2. And I need to figure out which intervals satisfy this inequality. So first thing we want to do is get everything to one side and a 0 on the other side. So I'm going to subtract 2 from both sides. Okay, now I need to make it one rational term on the left. So I need to rewrite this with a common denominator. So 2 has a denominator of 1 all the time, and 3x minus 2 has a denominator of x minus 3. So if we look at those two denominators, the common denominator would be x minus 3 times 1, which is just x minus 3. So we need 2 to have a denominator of x minus 3. So you multiply it by x minus 3 over x minus 3, and we get 2 times x minus 3 over x minus 3. Okay, so that expression needs to go back into our inequality. Okay, so now we can combine the numerators and denominators. So the denominators, we're not really combining, we're just making it 1 because they're the same. But the numerators, we can put together the like terms. So I'm just going to write it all out right now. So I just distributed that negative 2 into the parenthesis. And now I can collect like terms. And I get x plus 4 over x minus 3 is less than 0. Alright, so this looks more like what we're used to working with. We have to find some test points and find some regions here. So first we want to find some points that are going to define our regions. So we look at our numerator, set it equal to 0, and we get negative 4. We look at our denominator, set that to 0, and we get 3. So the points, areas we want to check, if we put them on a number line, make it a number line. Okay. Alright, negative 4 and 3. So at negative 4, we're going to use open circles because there's not an equal sign. It's just strictly less than. So open circle on negative 4, open circle on positive 3. So now that breaks our number line into 3 regions. We have this region over here, which is negative infinity to negative 4. We have the region in the middle, which is negative 4 to 3. And we have the region to the right of here, which is 3 infinity. Okay, now we have to pick some points in each region and decide if our inequality is true there or not. The way that your book does it, which I think is kind of cool, is just looking at signs. So we aren't actually figuring it all out. We're just looking at, is it positive or negative? If it's negative, it would be less than 0, so it works for our inequality statement. If it's positive, that's not less than 0, we don't include that region. Okay, so let's pick x is equal to negative 5. If I put negative 5 into x plus 4, what sign do I get? That's going to be a negative. If I put negative 5 into x minus 3, I'll get a negative. So together, x plus 4 over x minus 3, a negative over a negative is going to be a positive. Just a moment. Okay, I just made a table to organize our information a little better. So we got a positive result, meaning that negative infinity to negative 4 is not in the solution region. So now we got to try something between negative 4 and 3, and I always try 0 if it's possible. So this would be positive, this would be negative, so this one's going to be negative. So the first one was not in solution, and the second one is in solution. Because remember, we want something less than 0, and a negative would be less than 0. Then we can try something to the right of 3. So let's just try 4. So this would be positive. This would be positive. So the whole thing is positive. So not in solution. And so in the end, the only region that's in our solution set is the one that contains 0. This between negative 4 and 3. So our solution is negative 4 to 3. Always, we can check our answers by plugging in some values and making sure it works for the original equation as well. I hope this helps.